When you hear the name Rolls-Royce, you probably imagine luxury cars, quiet cabins, polished metal, prestige. But high above the clouds, that same name represents something far more powerful. Jet engines. Some of the most complex, precise, and powerful machines ever created by human hands. Today, we're inside Derby, United Kingdom, home to one of the most advanced aircraft engine factories on Earth. This is where engines are built that don't just fly planes, they carry entire civilizations across the sky. A factory that feels unreal. The moment you step inside, scale becomes meaningless. The building stretches upward like a cathedral of steel. Engines stand vertically, taller than houses. Cranes glide overhead in near silence. And yet, this isn't experimental chaos. This is routine. Every 20 days, a fully assembled wide-body jet engine leaves this facility, ready to power aircraft across oceans, continents, and time zones. To understand how that's possible, we need to start at the front of the engine, where thrust is born, the fan. At the very nose of a Rolls-Royce Trent XWB engine, the exclusive power plant of the Airbus A350 is the fan. It doesn't burn fuel, it doesn't create fire, but it generates most of the thrust. Massive blades, each razor-sharp at the leading edge, are fitted into a precision-machined fan disc. Between them sit annulus fillers, designed to smooth airflow to perfection. Every curve, every angle, every micron matters. At cruising speed, this fan moves tons of air every second, quietly pushing the aircraft forward. This is efficiency at its most extreme. Power from the back, turbines and shafts. While the fan dominates the front, the real power lives at the back. Hidden deep inside the engine are turbine blades, spinning at astonishing speeds, driven by exhaust gases hotter than molten lava. Each turbine blade can produce around 800 horsepower. Together, 68 blades generate over 50,000 horsepower, all contained inside a metal casing you could touch with your hands. A long shaft runs through the center of the engine, transferring that power forward to spin the fan. This is mechanical perfection under unimaginable stress. Building the core vertically. Jet engines aren't built like cars. The engine core is assembled vertically, stacked upward like a skyscraper. Compressors at the bottom, combustors in the middle, turbines at the top. As the engine grows, the factory floor itself moves. Platforms rise and fall so technicians can always work at eye level. Digital screens guide every step, displaying real-time models that ensure nothing is installed incorrectly. This isn't mass production, it's controlled precision. The marriage, fan meets core. Once complete, the fan and core are brought together in what engineers call the marriage. The engine is rotated from vertical to horizontal. The massive fan case is fitted. Before blades are installed, machines measure clearances smaller than a human hair. Too loose, efficiency drops. Too tight, failure becomes possible. When the fan blades are finally installed, the engine looks alive. But it hasn't proven itself yet. That happens next. The test facility, controlled violence. Every engine built here must survive testing. Inside the control room, engineers operate the engine like pilots. A throttle controls power, sensors monitor pressure, vibration, temperature, and stress, thousands of data points in real time. When the throttle moves to maximum power, the engine roars. But outside, almost silence. That's because the engine is inside a test cell, a building within a building, designed to contain sound, energy, and disaster. Before ignition, safety interlocks confirm every door is locked and every person is accounted for. Only then, the engine comes alive. Testing the worst-case scenario. Rolls-Royce doesn't just test engines when things go right, they test when everything goes wrong. Water ingestion tests simulate flying through violent storms, dumping massive volumes of water directly into the engine. Bird strike tests fire birds into spinning fans at high speed. Cold start tests freeze engines overnight and then demand flawless startup in extreme conditions. And sometimes they deliberately destroy parts. In fan blade off tests, an explosive bolt detonates a blade while the engine runs at full power. The engine must contain the blast and shut down safely. The energy involved is comparable to a car falling from a 100-foot cliff. If that happened mid-flight, you might spill your drink, but the aircraft remains safe. Fixing the past, the Dream Fix facility. Not every engine's journey is perfect. The Trent 1000, built for the Boeing 787 Dreamliner, experienced durability issues. The engines were safe, but certain parts wore out sooner than expected. To address this, Rolls-Royce created the Dream Fix facility. Here, engines are brought in, stripped down, upgraded, and returned to service as quickly as possible. Design fixes are applied, improving longevity and reliability. The challenge wasn't safety, it was making a great engine last as long as airlines and passengers expect. And that's being solved, engine by engine. A glimpse of the future, carbon fan blades. Among the engines in DreamFix sits something special. A test engine fitted with carbon titanium fan blades, lighter, stronger, and more aerodynamic than anything before. Early carbon designs saved weight but sacrificed airflow efficiency. These don't. Thanks to advanced 3D woven carbon fiber, these blades outperform titanium in both weight and aerodynamics. The result? Half a ton saved per engine. On a twin-engine aircraft, that's 1,500 pounds, meaning lower fuel burn or more passengers on every flight. This is aviation's next leap forward. The ultimate testbed, UltraFan. Now under construction is something even bigger, a new test facility set to become the world's largest indoor engine testbed. Built for Rolls-Royce's next-generation UltraFan, it can monitor up to 10,000 parameters in real time, streaming data directly into digital simulations. The building itself adapts. Floors rise to meet engines, massive airflow tunnels slow and silence exhaust so effectively that people outside may not even know an engine is running. Facilities like this are built once every 10 to 15 years. For the engineers involved, this is a once-in-a-lifetime legacy. More than machines. Standing inside Rolls-Royce Derby, one truth becomes clear. This isn't just engineering, it's responsibility. Every blade, every test, every calculation exists so millions of people can fly safely without ever thinking about what's happening beneath the wing. And that's the highest compliment engineering can receive, because when it's done right, you never notice it at all.